We'll now continue with section 2.5, discussing linear inequalities in two variables. We'll look again at a specific type of example, that where we have two linear inequalities joined by the word or. So let's recall that the word or means essentially the union of the two sets. And so we'll begin in much the same way. We'll take each of our equations, and instead of having the inequality, we'll replace it with an equal sign. Our goal here is to graph the two equations. So the first one, we have x plus y. Originally it was less than 4. We're now going to make it equal to 4 so that we can graph. We'll do a table of values, keeping in mind that often the x-intercept and the y-intercept are the easiest points to use. If we plug a 0 in for the x, we would have 0 plus y is equal to 4, and therefore y is equal to 4. That gives us 1 point that we can plot. If we look at the y value being equal to 0, we would have x plus 0 is equal to 4. Therefore, x is equal to 4. And that gives us the second point that we can plot. Similarly, we'll take our second equation, which is x is greater than or equal to 4, and we'll write it x is equal to 4. We'll remember on that one that if the equation only has one variable, that it is either a vertical or a horizontal line. Because the one variable is an x, we know that this is a vertical line. So now with that information, we will go to a graph and look at graphing each of these two equations. So our first equation, x plus y, is equal to 4. Recall that our 2 points we had were the point 0, 4 and the point 4, 0. And so we'll plot both of those points. Here is 0, 4, and here is 4, 0. We'll connect those two dots with a dotted line because recall that if this is a less than or a greater than without the equal to underneath, it graphs as a dotted line. For our other equation, x is equal to 4, we said that this was a vertical line made up of all the points where x is equal to 4. And so you can see that as we cross over to 4, we can draw our vertical line right here, and that will be the second equation. Because it is greater than or equal to, we'll draw it as a solid line. Now, once the two lines have been drawn, the next step is to choose a test point on one side of the line or the other and use that test point to determine where to shade. So for our first equation, let's pick as a test point 0, 0, which is here. We're going to take our original equation, which is x plus y is less than 4. We're going to plug a 0 in for x and a 0 in for y and look at the statement that we get. So our test value gives us the statement 0 is less than 4, which we know is true. Therefore, this solution set contains 0, 0 and is actually every point on that side of the equation. So I can go ahead then and shade everything to the left of my dotted line. For our other equation, x is equal to 4, we'll do the same thing. We'll choose a test point. In that case, I could still use 0, 0, Our equation was x is greater than or equal to 4, and if I'm using as my test point 0, 0, then I plug a 0 in for the x, and I get the statement 0 is greater than or equal to 4. We know that that is false, which means that 0, 0 is not in the solution set of x is greater than or equal to 4. So we don't want to shade on this side of our line, but we want to shade on the other side. So we're going to shade everything to the right of the x is equal to 4 line. Now notice that some of that is already shaded, and that's okay. We do have some overlap there between the two. But remember that the word or is talking about the union of the two sets. So it is this set union with this set, making up our solution set. So our solution is everything that lies inside the shaded region.